Dear student, today we are talking about database management system and our topic is SQL, structured query language. These are our outlines. What is SQL? Why SQL? History of SQL, SQL process, SQL command in which we show DDL, DML and DCL. What is DBMS? What is table? What is field? What is record or row? What is column? What is null value? SQL constraint. And then after we have seen number of keys. Why we need a key in DBMS and number of keys. So let's start. What is SQL? SQL is, as we know, that structured query language. SQL is an ANSI, American National Standard Institute standard, but there are many different versions of SQL languages. SQL is structured query language, which is a computer language for storing, manipulating, and retrieving data stored in a relational database. SQL is the standard language for relational database system. All relational database management system like MySQL, MS Access, Oracle, Sybase, Informix, Postgres, and SQL Server use SQL as a standard database language. Why SQL? Then there is a number of reasons. SQL allows user to access data in the relational database. Is allow to describe data. SQL allow to define data in database and manipulate that data. SQL allow to embed within other languages using SQL models, libraries and precompilers. SQL allows user to create and drop database and tables. It allows to create view, stored procedure, functions in a database. It allows user to set permission on tables, procedures and views. Thus in the history of SQL, in 1970, Dr. E.F. Tate of IBM is known as the father of relational databases. He described a relational model for databases. In 1974, structured query language appeared. In 1978, IBM worked to develop codes, ideas of released a product named System R. In 1986, IBM developed the first prototype of relational database and standardized by ANSI. The first relational database was released by Relational Software and it's later becoming Oracle. The SQL process. When you are executing an SQL command for any RDBMS, the system determines the best way to carry out your request. An SQL engine figures out how to interpret the task. There are various components included in the process. These components are query dispatcher, optimization engines, classic query engine, and SQL query engine, etc. Classic query engine handles all non-SQL queries, but SQL query engine would not handle logical file. Here see The process is going on as like this. SQL commands. The standard SQL commands to interact with relational databases are create, select, insert, update, delete, and drop. These commands can be classified into groups based on their nature. First, DDL, data definition language, command create, which is used to create a new table, a view of a table or other object in database. Alter command modifies an existing database object such as table. Drop command deletes an entire table, a view of a table or other object in the database. DML, data manipulation language. It is mostly used for insert, update and delete. Insert command is used to create a record. Update command is used to modify records, and delete command is used to delete records into a table. DCL, data control language. As a name, it is used to control the databases. Command grant, which is used to give the privilege to user. Revoke command, which is used to take back privilege granted from user. SQL RDBMS concept. RDBMS stands for Relational Database Management System. RDBMS is the basis for SQL and for all modern databases system like MS SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access. A relational database management system is a database management system that is based on the relational model as introduced by EF code. Now, what is table? The data 0 in RDBMS is stored in database objects called tables. The table is a collection of related data entries and it consists of columns and rows. Remember, a table is the most common and simplest form of data storage in a relational database. See the example of customer table. What is field? Every table is broken up into smaller entities called a field. The field in the customers table consists of ID, name, age, addresses and salaries, as we have seen in customer table. What is record or row? A record, also called a row of data, is each individual entry that exists in a table. For example, there are 7 records in the above customers table. Here we see the single rows of data or records into a customer table. Ramesh, ID is 1, 32, Ahmedabad and 2000. A record is a horizontal entity in a table. Now, what is column? A column is a vertical entity in a table that contains all information associated with a specific field in a table. For example, a column in the customers table is address, which represents location description and would consist of the following. Values is Ahmedabad, Delhi, Kota, Mumbai, Bhopal, MP, Indore, etc. What is null value? A null value in a table is a field that appears to be blank, which means a field with a null value is a field with no value. It is very important to understand that a null value is different than a zero value or a field that contains spaces. A field with a null value is one that has been left blank during record creation. SQL constraint. Constraints are the rules enforced on data columns on table. These are used to limit the type of data that can go into a table. This ensures the accuracy and reliability of the data in the database. Constraints could be column level, or table level. Column level constraints are applied only to one column, whereas table level constraints are applied to the whole table. First, not null constraints. By default, a column can hold not null values. If you do not want a column to have a null value, then you need to define such constraint on this column, specifying that null is now not allowed for that column. A null is not the same as no data, rather it represents unknown data. See the example. The following SQL creates a new table called customers and adds 5 columns, 3 of which ID and name and age specify not to accept nulls. Here see the SQL queries. Default constraint. The default constraint provides a default value to a column when the insert into statement does not provide a specific value. For example, the following SQL creates a new table called customers and adds 5 columns. Here, salary column is set to 5000 by default. So, in case insert into statement does not provide a value for this column, then by default this column would be set to 5000 value. See the SQL syntax of default constraint. Unique constraint. The unique constraint prevents two records from having identical values in a particular column. In the customer tables, for example, you might want to prevent two or more people from having identical age. Here, see the example. The following SQL is create a new table called customers and add 5 columns. Here, age column is set to unique so that you cannot have two records with the same age. See the SQL syntax. Age integer, not null, unique. Now, why we need a key? Key is help to identify any rows of data in a table. Keys allows you to establish a relationship between and identify the relation between tables. Keys help you to enforce identity and integrity in a relation. A DBMS key is an attribute or set of an attribute which helps you to identify a row or tuple in a relation. They allow you to find the relation between two tables. Keys help you to uniquely identify a row in a table by a combination of one or more columns in that table. Various keys in database management system. There is a number of keys we are using in database management system. Super key. A super key is a group of single or multiple keys which identifies rows in a table. A super key may have additional attributes that are not needed for unique identification. See the example here. Employee SSN number and employee number and names are super keys, which is sufficient to provide the unique identification of tuples. Primary key. Primary key is a column or group of columns in a table that uniquely identify every row in that table. The primary key can't be a duplicate, meaning the same value can't appear more than one in a in the table. A table cannot have more than one primary key. There are some rules for primary key. Two rows can't have the same primary key value. It must for every row to have a primary key value. The primary key field cannot be null. The value in the primary key column can never be modified or updated if any foreign key refers to that primary key. Here see the example. Student ID is working as a primary key for this table because of it is unique, provide the unique identification of student, and it never be changed, and always it is require not null value. Alternate key. The alternate keys is a column or group of columns in a table that uniquely identify every row in in that table. A table can have multiple choices for a primary key, but only one can be set as the primary key. All the keys which are not primary key are called an alternate key. In this example, student ID, roll number, email are qualified to become a primary key. But since student ID is the primary key, roll number, email becomes the alternative key. A candidate key. Candidate key is a set of attributes that uniquely identify tuples in a table. Candidate key is a super key with no repeated attributes. The primary key should be selected from the candidate keys. Every table must have at least a single candidate key. A table can have multiple candidate keys but only a single primary key. Some of the properties of candidate keys exist. It must contain unique values. Candidate key may have multiple attributes, must not contain null values. It should contain minimum field to ensure uniqueness. Uniquely identify each record in a table. See the example. In the example, student ID, roll number, and email are candidate keys which helps us to uniquely identify the student record in a table. Foreign key. Foreign key is a column that creates a relationship between two tables. The purpose of foreign keys is to maintain data integrity and allows navigation between two different instances of an entity. It acts as a cross reference between two tables as it references the primary keys of another table. See the example. In this example, we have two tables, teach and department in a school. However, there is no way to see which such work in which department. There is no actual ways. In this table, adding the foreign keys in department code to the teacher name, we can create relationship between two table, teach and department. This concept is also known as referential integrity. Compound key. Compound key has two or more attributes that allow you to uniquely recognize a specific record. It is possible that each column may not be unique by itself within the database. However, when combined with the other column or columns, the combination of composite keys become unique. The purpose of compound key is to uniquely identify each record in a table. In this example, order number and product ID can't be a primary key as it does not uniquely identify a record. However, a compound key of order ID and product ID could be used as it uniquely identify each record. Surrogate key. It is an artificial key which aims to uniquely identify each record is called a surrogate key. These kind of key are unique because these are created when you don't have any natural primary key. They do not lend any meaning to the data in the table. Surrogate key is usually an integer. See the example. In above example, show shift timings of the different employee. In this example, a surrogate key is needed to uniquely identify each employee. Surrogate key are allowed when no property has the parameter of the primary key in the table when the primary key is too big or complicated. Hope you enjoy. Thank you.